Okay, in this video we're going to look at properties of equality. Now some of these you may have already seen in previous courses in algebra or pre-algebra. The first property we're going to look at is called the reflexive property. And the reflexive property basically just says everything is equal to itself. You can kind of think of it as an expression that's looking in the mirror. You're going to see exactly the same thing on both sides of the equal sign. So for example, 17 equals 17. The measure of angle ABC equals the measure of angle ABC. These are examples of the reflexive property. Whatever's on the left side of the equal sign, the exact same thing is on the right side of the equal sign. The symmetric property of equality is similar to the reflexive property. It says that if A is equal to B, then B is equal to A. In other words, you can flip around what is on each side of the equal sign. For example, if x equals y, then we could say y equals x. Take what's on one side and put it on the other side. That's an example of the symmetric property. If the measure of CAT is equal to the measure of DOG, then we could say the measure of angle DOG is equal to the measure of angle CAT. We're just flipping it around. That's the symmetric property. The transitive property. The transitive property just says if A equals B and B equals C, then A equals C. And sometimes people think of this, the word transitive, as kind of being similar to the word train. And if you kind of think of these as being cars in a train, then if this is the locomotive, then this is the caboose, and the transitive property just kind of lets you take out all of the middle cars so that you can go straight from the locomotive to the caboose. So here's an example. If x equals y and y equals z, then we can use the transitive property to say x equals z. In other words, we're taking the locomotive and going straight to the caboose. Here's another example. If the measure of CAT equals the measure of DOG and the measure of DOG equals the measure of PIG, then we can say the measure of angle CAT equals the measure of angle PIG. So we have this kind of middle car in our train, angle DOG, and we're kind of taking that one out so we can go straight from the locomotive to the caboose. The substitution property, this is a property that you've already used many times in your algebra and pre-algebra courses. And the substitution property just says that if you have something that is equal to something else, you can substitute that value into another expression. For example, if A is equal to 4, and we have this expression that says B equals A plus 2, then I can take this value for A and I can substitute it for A in this expression. So then I would write B equals 4 plus 2. I just took this value for A and I substituted it in for A in this expression. Here's another example. If AB equals BD and AB plus BD equals AD, then once again I'm going to take this expression here and I'm going to substitute, since AB is equal to BD, I'm going to substitute this for the value of AB in this expression. And so I can write BD plus BD equals AD. In other words, everything in this expression is the same except for this piece of it where I've substituted the value BD in for AB. That is the substitution property. Now we're going to look at some properties of equality that we use most often when we're solving algebraic equations. So for example, the addition or subtraction property, this is actually two different properties, but they're very similar, so we kind of talk about them together. The addition property is just the property that you've used when solving equations. Anytime you add the same thing to both sides of an equation, you're using the addition property. So for example, if I had this equation that I'm trying to solve, the first thing that I would want to do is add 8 to both sides of my equation. Well, anytime I'm adding something to both sides of my equation, I'm adding the same thing to each side of the equation, I'm using the addition property. So this would give me 2x equals 24. That's the addition property. For this example right here, if I have the equation 2x plus 7 equals 25, the first thing I'm going to want to do is subtract the same thing from both sides of my equation. In this case, I'm going to subtract 7 from both sides of my equation, and that is 25 minus 7 is 18. This is an example of the subtraction property. I'm subtracting the same thing from both sides of my equation. The multiplication and division property, again, if I have an equation in which the first thing that I want to do, like in this example right here, the first thing I want to do here is I want to multiply both sides of my equation by, in this case, 3. That will get rid of my fraction. So if I'm multiplying this side of the equation by 3 and this side of the equation by 3, I'm using the multiplication property of equality. Here's an example in which, in order to solve for x, I want to divide both sides of my equation by the same number, in this case 4. So if I divide both sides of my equation by the same number, I'm using the division property. The distributive property, again, this is a property you have used before. Anytime you have a number multiplied an expression inside a set of parentheses, you are going to be distributing that number through the parentheses. So a times b plus c equals ab plus ac. For example, you have an equation that looks like this. Your first step is going to be to use the distributive property to distribute the 2 through the parentheses. So this would give you 14x minus 6 equals 8. And you just use the distributive property. The simplifying property, this is just a way of saying what you are doing anytime you are simplifying an expression. So for example, let's say this is your given equation. And the first thing you would want to do in this case is you're going to want to use the addition property of equality. You're going to want to add 4 to both sides of the equation. And I'm going to write this out, instead of writing plus 4 and plus 4 like I normally would, I'm going to go ahead and write this out like this. So I take this and add 4, 4x minus 4 plus 4 here, and then 8 plus 4 here. Right? And so this, I would say, this is the addition property. Now, the next thing I'm going to do is, since negative 4 plus 4 makes my 4's go away, and since 8 plus 4 is 12, well, what I've done here is I've used my simplifying property. And essentially, I have said negative 4 plus 4 becomes 0, so this goes away. Excuse me, that should be a 4x. Negative 4 plus 4 goes away and leaves me with just 4x on this side of the equation. So I've simplified this to just 4x. Same thing on the right side of the equation, 8 plus 4. I've simplified 8 plus 4 into the expression 12. So that's the simplifying property. Now I can do one more step here to go ahead and finish solving my equation. I divide both sides of my equation by 4. That's going to be the division property. Remember, anytime I divide both sides of my equation by the same number, I'm using the division property. Well, once again, I'm going to simplify now. 4x divided by 4 is x, and 12 divided by 4 is 3. I'm just replacing 12 divided by 4 with a simpler expression, which is 3. I'm replacing 4x divided by 4 with a simpler expression, which is x, or 1x. So again, this is the simplifying property.